Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is for Course 2, Lesson 4-9, Solving Inequalities by Multiplying or Dividing. Okay, now we will see in division and multiplication, there are going to be times where we have to pay careful attention to what we're doing because multiplying or dividing by a negative number causes the inequality symbol to reverse in order to keep the inequality statement true. So just kind of keep that in the back of your mind as we're going through, and I will be pointing that out to you as well, but keep that in the back of your mind. We'll start off with the division property of inequality, and that tells us if you divide each side of an inequality by the same positive number, the direction of the inequality remains unchanged. Okay, so if it's a positive number, it's not going to change anything. So let's look at this. 9 is greater than 6, so 9 divided by 3, which is 3, is going to be greater than 6 divided by 3, which is 2. So that remains true. Similarly, 15 is less than 20, so 15 divided by 5 is going to be less than 20 divided by 5, because this gives me a 3, that gives me a 4, 3 is less than 4. The inequality symbol remains unchanged. Okay? So algebraically speaking, if A is greater than B and C is positive, then A divided by C is greater than B divided by C. If A is less than B and C is positive, A divided by C is less than B divided by C. Okay? So basically, when you're dividing by a positive number, you're not going to change anything. However, if you divide each side of an inequality by the same negative number, the direction of the inequality symbol is reversed. Okay, this is the part that gets a lot of people. So this is the part that I was referring to as we got started. So what that tells us is if 6 is greater than 12, or 16 is greater than 12, so negative 16 divided by negative 4, which happens to be negative 4, and 12 divided by negative 4, which is negative 3, I have to reverse my inequality symbol and say less than, because 16 divided by negative 4 is less than 12 divided by negative 4. So in order for that to be true, the inequality symbol is reversed. Similarly, 10 is less than 18, so 10 divided by negative 2, which is negative 5, is going to be greater than 18 divided by negative 2, which actually gives us negative 9. Okay, so when I divide both sides by a negative number, a less than is going to reverse to a greater than. Algebraically speaking, if A is greater than B and C is negative, then A divided by C is less than B divided by C. And if A is less than B and C is negative, then A divided by C is greater than, let me start over, if A is less than B and C is negative, then A divided by C is greater than B divided by C. So it reverses the inequality symbol so that my mathematical statement remains true, or the inequality remains true. Okay, something similar happens in multiplication. If you multiply each side of an equation by the same positive number, the direction of the inequality symbol remains unchanged. So 12 is greater than 8, so 12 times 2 is greater than 8 times 2. Again, check it real quickly. You see that 24 is greater than 16. Similarly, 3 is less than 6, so 3 times 4 is less than 6 times 4. 3 times 4 is 12. 6 times 4 is 24. So the numbers there show you how that is true. So algebraically, we can go on to say if A is greater than B and C is positive, then A times C is greater than B times C. If A is less than B and C is positive, then A times C is less than B times C. Nothing changes. Now, here's the part again where there's the special situation. If you multiply each side of an equation by the same negative number, the direction of the inequality symbol is reversed. So arithmetically, that shows us that 6 is greater than 2, so 6 times negative 3 is going to be less than 2 times negative 3. This is going to be negative 18. This is negative 6. Negative 18 is less than 6. So you have to reverse that inequality symbol for the statement to remain true. Similarly, 3 is less than 5, so 3 times negative 2 is going to be greater than 5 times negative 2, which would be negative 6 is greater than negative 10. So we would have to reverse that in order for our statement to remain true. If A is, algebraically speaking then, if A is greater than B and C is negative, then A times C is less than B times C. Okay, so the symbol reverses because C is negative. If A is less than B and C is negative, then A times C is greater than B times C. Okay, so here are your algebraic statements. Here are some number examples or arithmetic examples to prove what we're trying to say here. Okay. All right. Let's go on and look at a couple of examples. And the first one is about a woodworker. Okay, a woodworker makes a profit of $30 on each picture frame that is sold. Write an inequality to describe the number of frames the woodworker must sell to make a profit of at least $500. So the number of frames times the profit on each frame is greater than or is at least $500, which is greater than or equal to. So if F is the number of frames, multiply that by the profit on each frame of $30. That needs to come out to greater than or equal to $500. Okay, at least is a greater than or equal to statement. So 30F is greater than or equal to 500. We'll divide each side by 30. 30 is positive, so nothing's really going to change here as far as needing to reverse the inequality. So you might even want to write yourself a note. Don't reverse the inequality symbol. Okay, so if you work this out, you see that F is greater than or equal to 16.6 repeating, or 16 2/3. You can't sell a fraction of a frame, so you're going to have to round up to the nearest whole number. So F is greater than or equal to 17. That means that the woodworker must sell at least 17 frames in order to make $500 profit. Okay. So at this point, if you need to pause your the video and just kind of go back through the numbers and think through the process, it might be a good time to do that. Okay. Number 2, solving inequalities by multiplying. So we have solve B divided by negative 3 is less than 12. Okay, since this is division by negative 3, we're going to multiply each side of the inequality by negative 3 and reverse the direction of the symbol. Okay, so I'm going to do that right now so I don't forget, and then I'm going to do it here too so I don't forget. Okay, and I'm going to be multiplying by negative 3, and you can write this as negative 3 over 1 if you like on the fraction side, because remember that cross cancels out and you're left with B over 1, which is B, and then negative 3 times negative 12 which is positive 36. Okay. So B is greater than 36. If you put 36 in here, you would get the equality statement. If I want to pick a number larger than that, I might try maybe 39. 39 divided by negative 3 is negative 13. So that checks. Again, we'll go over some checks together in class, so that might be something you make a note to ask about. Have the quick checks completed, and we'll talk about this next time we meet in